Today I've got something really interesting to share, especially for those of you who are into Homelabs or setting up your own personal cloud server. This is the new LCMD Microserver, along with an optional add-on called the AI Pod. This is a compact computing module designed to boost system performance for AI-related tasks. Together, these two devices form a powerful and accessible Homelab solution. They're designed to help even less experienced users get an advanced personal server up and running quickly and easily. You can run Docker containers, host media servers, set up your own Git server, and even build an AI searchable photo and video library. So let's get these devices unboxed and do some testing on them. First up, we've got the microserver, and can we just take a moment to appreciate this packaging design? This is easily one of the coolest product packages and unboxing experiences I've seen. Underneath the magnetic flaps is an orange acrylic cover. And beneath that is the LCMD Microserver. Alongside it are two accessory boxes. There's also a sleeve in the front which probably has some documentation in it. The server and accessories are all held in place and protected by high density foam. In the first accessory box, we've got an Ethernet cable and an international power adapter for the power supply. The second one has a 19V 120W power supply with a barrel jack connector, and there's also an included mains lead. The sleeve we saw earlier has a set of sequenced instruction cards to guide you through getting the server set up and running, which is also quite a unique way of presenting a quick start guide. Taking a look around the microserver, the front and sides don't have anything on them. The top has ventilation holes on the four corners. The bottom has even more ventilation, as well as some orange rubber feet. And on the back we've got all of the ports, which are conveniently labelled. We've got the power input, an HDMI 2.1 port, two USB 3.2 Type-C ports, three USB 3.0 ports, an audio jack, a 2.5 gig networking port, and then a mode and power button. Above the ports are some vents which look like they're for the CPU heatsink, and below them's an open ventilation grill, which is probably for the drive bays. Speaking of drive bays, and something we'll take a look at in a bit more detail later, internally the microserver also has space for two 2.5-inch drives and four M.2 NVMe drives. Overall, the build quality feels really good. All of these grey bits are aluminium, so it feels solid and well built. I also really like the orange and white futuristic styling. The microserver is quite compact. It measures 115 by 115 by 120mm high. Internally, it's powered by an Intel Core i5-13500H CPU. This is a 12-core mobile processor with 4 performance cores running at up to 4.7 GHz and 8 efficiency cores running at up to 3.5 GHz. Being a 2023 chip, it has Intel's Iris Xe graphics. This has 80 execution units running at up to 1.45 GHz, which is probably okay for what this server is designed to do. It looks like they'll be offering the microserver in 3 variants, which vary the RAM and storage capacity. This one's got 16 gigs of DDR5 RAM running at 5200 MHz, and then a 2TB storage SSD. Their top model will have 64GB of RAM and a 4TB SSD. While we're on the topic of storage, in addition to the 500GB OS drive, it's also got 4 M.2 ports which allow 2280 size drives to be installed for a maximum capacity of 64TB. This is based on using 16TB drives though, which are not particularly easy or cheap to come by. It's also got 2 SATA 3 bays that allow another 8TB each, so the total internal storage capacity is 80TB. That's if you've got a small fortune to spend on SSDs. Realistically, you can probably install around 20TB without breaking the bank. It's also got Wi-Fi 6E through an AX210 chip. The enclosure is quite cleverly designed, with the internal sliding out through the back port cover after removing some screws at the bottom. This is how you add additional drives to the server, and my only complaint with this is that they've used Torx screws for the bottom panel and then Phillips head screws for the retaining bracket. It would be nice to have these consistent. Now let's get it booted up. And this is where I was most impressed. Usually these kinds of products have decent hardware and then fall apart when you start testing the software, but this was very much not the case for my setup experience. After plugging it in, you'll need to install their app on your mobile phone to get started. The microserver runs LCOS, which is their own software based on Debian. Once setup has been completed, which is less than a 5-minute process that has been very well automated, you'll end on the home screen. You can then take your mobile phone, computer or tablet out of your local network, and the system has already set up encrypted remote access, which allows you to access your files and services from anywhere in the world. It does this through NAT traversal, like Tailscale, so you don't need to set up port forwarding or mess around with your network settings. The ease of this setup process was really impressive, but also a bit concerning. So I had a chat with their development team, which I'll get to a bit later on in the video. There's also a client app available for PC and Mac. From here you can start managing and setting up your storage pools and permissions, install apps, change settings, and view and manage your media. And honestly, it's pretty polished already, considering this is a product still in development. They have one-click installs for over 1,000 apps, including popular ones like Jellyfin, Nextcloud, Git servers, and CI pipelines. I tried out installing Jellyfin, and it worked first time without requiring any advanced setup. You aren't forced to use the desktop client. You can set up a range of shares so that the microserver acts like a traditional NAS, allowing you to transfer files directly to and from the device, both in Windows and on your Mac. The LCMD Microserver also has the ability to act as a smart TV when connected to a display through its HDMI port. The app on your phone then becomes a remote that you can use to interact with it, and you can access all of the apps and stored media content. Now that we've taken a look at the microserver, let's check out the AI pod. As I mentioned earlier, this is an add-on to the microserver which adds more computing power to the system for machine learning workloads. Unlike the microserver, which is a standalone product, the AI pod can't be used alone, and it needs to be paired with the microserver. The AI pod is also really well packaged, but in a different way. We've got a branded foam pad at the top, and then the AI pod beneath it. This also feels very solid and looks like something out of a sci-fi movie. It kinda reminds me of a building from StarCraft, if any of you have played that back in the day, although I might be showing my age with that comment. Alongside the AI pod is the instruction manual and then a box labeled charger. This has the power supply in it, which outputs 12 volts at up to 96 watts. I was a little disappointed that all of the other cables and accents are black, and this power supply is white. But after asking their tech support, it seems like this is a temporary power supply suitable for my region, and the one shipped out with the final product will be black too. Taking a look around the AI pod, the front is actually a ventilation grill, and you can see right through to the back of the enclosure. The two sides are solid, the top has fine ventilation mesh, and the bottom has a removable cover plate. On the back, similar to the microserver, we've got the power and mode buttons, then a USB 3.2 Type-C port, two USB 3.2 ports, an HDMI 2.1 port, a 2.5 gig and a 10 gig network port, and then the power supply input. The 10 gig network port is a bit of a strange addition, since the microserver only has a 2.5 gig port, and this is designed to talk to that. But it's included because they're using Nvidia's Jetson AGX Orin development board, so internally this isn't a custom built piece of hardware. Styling is designed to match the microserver, so it's the same grey aluminium housing with black accents. I think the pair look really cool together. The AI pod has a slightly larger footprint than the microserver, measuring 130 by 144 mm, but it only stands 61 mm high, so it might look a bit smaller. The Jetson Orin board has an ARM CPU featuring 12 Cortex A78 cores that can run up to 2.2 GHz. And then an Nvidia GPU with 2048 CUDA cores, 64 Tensor cores, and 64 gigs of LPDDR5 video memory. This adds an impressive 275 TOPS of processing power to the microserver, while only drawing around 30 to 60 watts. Internally, it's also got a Wi-Fi 6 module and a 1TB WD Black NVMe SSD as the OS drive. It's got a second drive bay, but at this stage I don't think you'd really need to use that on the AI pod. To pair the pod with the microserver, you need to install a separate desktop app, but the pairing process is also quite easy to work through. With this added, you now have access to some AI-based apps that take advantage of the pod's processing power, so you can do things like image and video generation locally. Let's try out image generation first. That worked quite well. The first and last images aren't quite what I was going for, but the other two are fairly good. You can also do different image styles, like generate cartoon images. And even some more difficult inputs, although this model clearly has a problem with numbers. None of these images have 4 dogs, and this one has 2 heads. But overall this feature works pretty well. Now let's try video generation. This works in a similar way, but it takes a bit longer as it has to generate multiple frames. That came out much better than I expected. It's not amazingly realistic, but this is really impressive for a video generated in a couple of minutes on a local piece of hardware drawing less than 100 watts. Let's try another one. So that also came out quite well. One of the features that I really like is the added search functionality to your photo albums. You can give it very specific queries, and in my small sample library it's very accurate. This is a really useful feature if you've got thousands of photos and you don't recall when you took a particular photo, but you do remember a small detail in it. There are also a whole lot of other AI-based features that I could make a separate video on, but some of the more useful ones are the ability to translate text locally in the browser like this. And you can even run a local language model similar to ChatGPT. So that's an overview of some of the features and capabilities of the LCMD Microserver and AI Pod. So how they're going to be priced. This version of the microserver with 16 gigs of RAM and 2 TB of storage is set to launch at $769, with an eventual recommended retail price of $1,400. This will go up to $1,159 for the 64 gig version with 4 TB of storage. The AI Pod will launch at around $2,489, with an eventual retail price of $3,600. They'll also have a range of combo deals with launch pricing between $3,228 and $3,618. My feeling on the microserver pricing is that the launch prices are quite fair, but the recommended retail prices are higher than I'd expect. The AI Pod seems quite expensive, even at the launch price. They do both use more premium WD black drives and crucial RAM, so they haven't cut corners with no-name brand components. But the AI Pod can't be priced near where a used A4000 or 3090 GPU would be a similarly priced alternative, as these would be a more powerful option. If they do, then the AI Pod will have to seriously prove its worth in software. So overall, this is a really impressive system, but now let's talk about privacy. One of the concerns that people are probably going to have with a product like this is that it's running a lot of pre-configured software with very little disclosure on what is and isn't being shared with the manufacturer. And there's some good and bad news here. The system's running a custom OS with quite a few proprietary layers, and while that makes it capable and offers a lot out of the box, at this stage there's limited transparency on exactly what it's doing in the background. I compiled a long list of questions and spent a lot of time talking with LCMD's developers, trying to determine what information they have access to and how this information is used, and I'll try to present a summary in the best way that I can. I'll post a full list of questions and answers on my blog, if you'd like to explore them yourself. The LCMD microserver is designed with decentralization and privacy as its core selling point, which means that users naturally want to bring as much in-house as possible. But on the flip side, LCMD are also trying to make the system as user-friendly and easy to use as possible, which they've really nailed. The platform's custom client app enables powerful features that just work. You don't have to be a whiz with Docker containers or have any advanced networking knowledge to get the microserver up and running. Most people aren't able to set up remote access to their home networks in a secure way, so there's a balancing act here which they're trying to navigate. From what I've found through testing and in talking to the developers, the server prioritizes direct peer-to-peer communication using asymmetric encryption, and the private keys are stored locally on the device. If both devices can be reached via hole punching, then traffic flows directly peer-to-peer. This falls back to relay traffic if that process fails, quite similar to how Tailscale works. For more advanced users that want a bit more transparency and control, You can also set up your own NAT traversal through Headscale, which is one of the pre-configured apps it offers. Local storage is also encrypted, and the encryption keys are again stored locally on the device, so don't forget your password or your data will be lost. The server only requires internet access for the initial setup and app installation. You obviously also require an internet connection for remote access, but if you don't need that and the initial setup is all you require, then you can isolate the system from the internet and it will continue to function on your local network. At the very extreme end, the microserver's BIOS is also unlocked, so if the software isn't for you, then you can install your own operating system on it if you'd like to. Although for this particular product, the software is a large part of the user experience, so it probably doesn't make much sense to do so. With all that being said, the microserver still uses proprietary software, like its own VPN protocol, which unlike open standards like WireGuard, hasn't been independently audited. Its dependency on a central server is limited but not zero, and although you could potentially configure it yourself to be zero, I wouldn't say that the system is 100% trustworthy, but it's about as close as you can get without them making the whole software package open source too. So that's the LCMD Microserver and AI Pod, a seriously powerful private cloud and AI edge device combo that's really easy to set up and use. Performance is great, the user interface is very well polished, and its AI features are all genuinely helpful, not just for party tricks. I do think LCMD could benefit from being very open about what's running under the hood, especially for a product that's designed around privacy and user control, but the same could be said for most cloud and data storage companies. Let me know what you think of the LCMD Microserver and AI Pod in the comment section below, and if this is something you can see yourself using for your Homelab or personal cloud. I'll leave a link to their Kickstarter campaign in the video description. As with other crowdfunded products that I've reviewed, keep in mind that crowdfunded projects cover some level of risk, and there's no guarantee that the final product will live up to the promises made in the campaign. Thanks for watching, don't forget to like the video if you enjoyed it, and subscribe for more tech and electronics projects, tutorials and reviews.